For this problem, we're supposed to find how many paths of length 3 there are in this directed graph. So first, I'm going to write out what the paths are. So A goes to A, B, and C. B goes to B and C. And C goes to just A. Okay, so now I'm going to start making the tree. So you can pick to start with any node you want. So I'm going to start with A, and I'm going to write out where A goes to. So A goes to A, goes to B, and it goes to C. So now I'm going to do it again. So A goes to A, B, C. B goes to B and C, and C goes to A. So now I have the paths of length 2, but I need the paths of length 3. So I'm going to do this one more time. So A goes to A, B, C. B goes to B and C. C goes to A. B goes to B and C. C goes to A. And A goes to A, B, and C. So this graph tells us all the paths that start at A, but now we want to find out the paths that start at B. So we make a new tree that starts with B. So we look back at the left, and we see that B goes to B and C, and then do it again. So B goes to B and C, C goes to A, and then B goes to B and C, C goes to A, and A goes to A, B, and C. So now we finished the B graph. So now we can make the C graph. So I'm going to start that here. So C goes to A goes to A, B, and C, A goes to A, B, C, B goes to B and C goes to A. So now I've made 3 trees which represent all the paths of length 3 in this directed graph. So in order to find out what number that is, I need to count up all the letters in this final row here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there are 24 paths of length 3 in this directed graph.